Hello students, let us continue the discussion on polynomials. Quickly we'll recall what we had studied in our previous session. We had a linear polynomial of type ax plus b where a not equal to 0. This type of a linear polynomial will have only one 0. Let alpha be the 0. The relationship between 0 and the coefficient is given by minus b by a. We also had a quadratic polynomial of type ax square plus bx plus c with a not equal to 0 to have two zeros. Say alpha and beta are the zeros, then we have these two relations. Sum of zeros is minus b by a and the product of zeros alpha into beta is c by a. We also had a cubic polynomial of type ax cube plus bx square plus cx plus d where a not equal to 0. The number of zeros are alpha, beta and gamma. The relationship between zeros and the coefficients are sum of the zeros alpha plus beta plus gamma is minus b by a. Sum of the product of two zeros taken at a time alpha beta plus beta gamma plus alpha gamma is c by a and the product of zeros alpha into beta into gamma is minus b by a. Here you look at this quadratic polynomial. The number of zeros are 2, alpha and beta. The sum is alpha plus beta, which is equal to minus b by a. What is this minus b? It is the coefficient of x and a is the coefficient of x square. Look at all the denominators. They are the coefficient of the first term. When the expression is expressed in decreasing order of their degrees, we always consider first term's coefficient in the denominator. How do you remember for the examination? Always it starts with a negative. Look at the linear polynomial, we have minus b by a. Look at the sum and the product of quadratic polynomial. The first is minus b by a. The next is c by a, it's positive. So first is negative, then positive. Look at the cubic polynomial. We have minus b by a, c by a, minus b by a. Alternately, a negative and a positive is there. So it's easy to remember. We shall make use of this to solve one more question related to relationship between the zeros and the coefficient of polynomial. Let's take a question. If alpha and beta are two zeros of quadratic polynomial, p of x equal to 2x square minus 3x plus 7, evaluate. First one is 1 by alpha plus 1 by beta. How to solve this? To solve this, first we have to consider the given polynomial p of x, which is equal to 2x square minus 3x plus 7. In this, A value is 2, B value is -3 and C value is 7. Sum of the zeros for this quadratic polynomial is minus b by a, which is minus of minus 3 by 2, which is positive 3 by 2. Product of the zeros alpha into beta is c by a, so it is 7 by 2. Now let us consider the first case, 1 by alpha plus 1 by beta. To find this particular value, let me take LCM. LCM is alpha into beta. We get beta plus alpha in the numerator, which is same as alpha plus beta. We know alpha plus beta is 3 by 2 and alpha beta is 7 by 2. These two of the denominators in each numerator and denominator will cancel, getting 3 by 7. So this 3 by 7 is the value of 1 by alpha plus 1 by beta. Let us take the second question here, alpha square plus beta square. How do we find alpha square plus beta square? We know this, alpha plus beta as 3 by 2, square on both the sides. What do we get by squaring? We get alpha plus beta whole square equal to 3 by 2 whole square. Square this, use the identity is a plus b whole square, which is a square nothing but alpha square plus b square nothing but beta square plus 2 times of alpha beta is 2ab term, which is equal to 9 upon 4. We know the value of alpha beta. Let's substitute in this term. We get alpha square plus beta square as 9 upon 4 minus twice. Instead of alpha beta, we need to substitute 7 upon 2. This 2 will get cancelled. We'll be getting 9 by 4 minus 7. LCM is 4. We'll be having 9 minus 4 times 7 is 28. 28 subtracted from 9 will be minus 19 upon 4. Therefore, the value of alpha square plus beta square is minus 19 upon 4. Look at third one. Let me again write alpha plus beta value. We have 3 by 2 and alpha beta value we have 7 upon 2. In the third one, we are asked to find the value of alpha cube plus beta cube. Once again, let me take the sum alpha plus beta as 3 by 2. Now we need to cube on both the sides. So we get alpha plus beta whole cube equal to 3 upon 2 whole cube. We know this identity. A plus b whole cube is a cube plus b cube plus 3 times ab multiplied to a plus b. Let's use that. We will be getting alpha cube plus beta cube plus 3 times alpha beta multiplied to alpha plus beta, which is equal to 3 cube is 27 upon 8. 2 cube is 8. Now we have this value alpha beta and alpha plus beta. Let's substitute that. Let me transpose this complete term. 3 times alpha beta times alpha plus beta. I'll transpose it. I'll be getting alpha cube plus beta cube as 27 upon 8 minus 3 times. Instead of alpha beta, I need to write 7 upon 2. Instead of alpha plus beta, I have to substitute 3 upon 2. Simplify this further, we'll be having 27 upon 8 minus 7 times 3 is 21. Multiplied to 3 is 63 upon 4. This is same as 8 is the LCM. We'll be having 27 minus 126. Which is minus 99. Minus 99 upon 8. This is the answer for alpha cube plus beta cube. Let me take the fourth one. The fourth sub-question we have is 1 by 2 times alpha minus 3 plus 1 by 2 times beta minus 3. Let us take LCM of these denominators. Its product 2 alpha minus 3 times 2 beta minus 3. So the numerator we get 2 beta minus 3 added to 2 alpha minus 3. This minus 3 added to minus 3 becomes minus 6. This 2 times alpha and 2 times beta I'll take 2 as common. I'll be getting twice alpha plus beta minus 6 upon. Let me multiply this 2 alpha to both these terms. I'll be getting 4 times alpha beta minus 6 times alpha. Now I shall multiply minus 3 to both these terms. I get minus 6 times beta. Negative of negative becomes positive 9. Further, I'll write this as twice alpha plus beta minus 6 divided by 4 times alpha beta minus 6. I'll take common in these two terms. 6 times of alpha plus beta plus 9. Now we have this alpha plus beta values. Let's substitute in this. You'll be getting twice alpha plus beta is 3 by 2 minus 6 divided by 4 times alpha beta is 7 upon 2 minus 6 times of alpha plus beta is 3 by 2 plus 9. Simplify this. 2 will get cancelled. 2 times is 4. 2 3 times is 6. Simplify this. Let me write it this part. So we get 3 minus 6 upon twice 7 is 14 minus 3 times is 9 added to 9. This 9 and minus 9 get cancelled. You'll be getting minus 3 upon 14. So the value minus 3 upon 14 is for 1 by twice alpha minus 3 plus 1 by twice beta minus 3. Let us study another very important concept in this chapter, division algorithm for polynomials. Here you will be given two polynomials, say f of x and g of x. Suppose the degree of f of x is larger than the degree of g of x, then we can divide the polynomial f of x by the polynomial g of x. This q of x is some quotient. When we divide f of x from g of x, we'll be subtracting the product g of x into q of x from the given polynomial f of x. When we subtract it, we get some remainder. We have learned in our previous chapter division algorithm, dividend will be equal to divisor into quotient plus the remainder. The same concept is very much applicable for polynomials also. F of x will be g of x into q of x, which is a divisor into quotient plus the remainder. In some cases where g of x is a factor of f of x, if one polynomial is factor of another polynomial, we will be getting remainder as 0. Or else we have to continue our division, long division, till we get degree of the remainder lesser than the degree of divisor. We shall understand this by solving more and more questions related to division of polynomial. We will be using a long division method. Let us take few examples and try and understand how to divide one polynomial from the other. Let me take an example. Say I'll divide 2x to the power 4. I'm taking a biquadratic polynomial. 2x to the power 4 minus 3x cubed minus 3x square plus 6x minus 3 from simple polynomial x square minus 2. Observe, this is our f of x. F of x is 2x to the power 4 minus 3x cubed minus 3x square plus 6x minus 3. And one more polynomial is g of x, which is x square minus 2. Observe the degree of f of x. We have the degree 4. G of x has the degree 2. So I will divide. Here I am following a long division method. Remember, we have to use this long division method. X square minus 2 is the divisor. I have to divide 2x to the power 4 minus 3x cubed minus 3x square plus 6x minus 3. I have to divide this. What should be multiplied here? The quotient, what should be considered so that I'll get 2x to the power 4. To understand that, let me write it here. The first term of the coefficient is, the first term of the quotient is x to the power 4. I have to divide by square. I I'll be getting 2x square. So I'll write here 2x square. On multiplying, we get 2 times x to the power 4. I need to multiply this 2x square to minus 2 also. I'll be having minus 4 times x square. Here there is a cube term. Here I am having a square term. So it is always better not to write that square term there. So let me erase that part. Eraser. Let me erase this part. Better I'll write square term below the square term. So I'll write minus 4 times x square below minus 3x square. Always remember, while dividing, we always change the sign of the expression, the terms, and we subtract. In the subtraction, we are adding by changing the sign. So this positive 2x to the power 4 minus 2x to the power 4, they get cancelled. We will be having minus 3x cube. Here we see this is a larger plus 4x square, and then there is a smaller number minus 3x square. On simplification, it becomes positive x square. The remaining terms I have to carry forward. I'll write them. Now how to get the second term of the coefficient? This was the first term. How do we get the second term? Second term, we obtain it by taking minus 3x cube and divide by x square. We will be having minus 3x. So this minus 3x is the second term of the coefficient. I'll write it here, minus 3x. So if minus 3x is multiplied, I'll be getting minus 3x cube. Now you multiply this minus 2 with minus 3x, you get positive 6x. Where shall I write? Should I write it below x square? No, I have to write it here. So it is positive 6x. Once again, I am changing the sign and adding them. By adding, we get these two terms getting cancelled. Then having square, these two terms also get cancelled. Minus 3. How do we get the third term of the coefficient? I have to continue division because the degrees are equal. If the degree of the remainder is smaller only, I have to stop. So the third term of the coefficient is, I have to divide this x square by x square. 1 is the third term, so it is positive 1. So x square minus 2. Let me change the sign. This x square will get cancelled. This minus 3 plus 2 is minus 1. So what did we get? We got the remainder as minus 1. I have to stop my division at this step because the degree of the remainder here is 0. The degree of the divisor is 2. So when we are getting degree of remainder r of x smaller than degree of divisor g of x, I have to stop my division process whenever I get this type. Therefore, on division, get quotient as minus 2x square minus 3x plus 1 and remainder as minus 1. So let me mention it here. We got quotient q of x as 2x square minus 3x plus 1 and the remainder r of x as minus 1. Had it been minus 2, if minus 2 was there here, we would have got remainder 0. Then we would have said that x square minus 2 is a factor of f of x. We shall solve some more question to understand division properly. Remember, always in long division method, the signs are very important. The sign of the coefficients are very important. Somewhere you miss the sign. Instead of minus, if you have written plus, the whole thing goes wrong. So you should be very careful while dividing one polynomial from the other polynomial. Let us take one more question. Now the question is slightly different. Check whether x square plus 3x plus 1 is a factor of 3x raised to the power 4 plus 5x cube minus 7x square plus 2x plus 2. Now we have to find out whether the given polynomial g of x is a factor of another polynomial f of x. When this becomes the factor of another, when we divide, we have to get remainder as 0. If the remainder we get is 0, then we can say it is a factor. So let's check by long division method. Let me write this x square plus 3x plus 1 as a divisor. Dividend is 3x to the power 4 plus 5x cube minus 7x square plus 2x plus 2. Remember, in the examination, always you have to cross check whether you have taken the same question while solving. You have to cross check it. X square plus 3x plus 1, 3x raised to the power 4 plus 5x cube minus 7x square positive 2x plus 2. It's very important to cross check. Now I'll not write first term, second term, third term of coefficient. You can think and you can solve it now. 3x to the power 4, when we divide by x square, we always get 3x square. So 3x square is the first term. On multiplying, I'll get 3x to the power 4 plus 3 3s are 9 x cube plus 3x square. Remember, we'll change the sign and add them. First term they get cancelled. Positive 5 and negative 9, we get the result as 4. So minus 4x cube is negative 7 and negative 3. When we add, we get negative 10 x square. These two terms carry forward. Now look at minus 4x cube is the first term. On division, by x square, we get minus 4x. So minus 4x is to be multiplied, we get minus 4x cube minus 12 times x square minus 4x. Once again change the sign. This minus 4x cube will cancel. Negative 10 and positive 12 on addition, we get positive 2x square, positive 6x and plus 2. Now look at this first term, 2x square. Here the first term is x square. If 2x square is divided by x square, we have this plus 2. So 2 has to be multiplied, so plus 2. So 2x square plus 6x plus 2. Change their sign. Look at carefully. 2x square minus 2x square will cancel. 6x minus 6x will cancel. Positive 2 minus 2 will cancel. We will be having no remainder. What does it mean? It means that x square plus 3x plus 1 is factor of 3x raised to the power 4 plus 5x cube minus 7x square plus 2x plus 2, because remainder is 0. So whenever this type of question is there, divide it using long division method. If the remainder becomes 0, then the given polynomial is factor of another polynomial. Very simple. Sometimes they may ask a tricky question like what must be added to polynomial f of x equal to 4x to the power 4 plus 2x cube minus 2x square plus x minus 1, so that the resulting polynomial is exactly divisible by x square plus 2x minus 3. Let me consider this as say g of x. Whenever this type of question is there, we will do this long division. We will divide f of x by g of x. So we will be subtracting g of x into q of x, where q of x is a quotient and the remainder is c of r of x. So we get this result f of x is equal to g of x into q of x plus r of x. Suppose if I transpose this, I will be getting f of x minus r of x equal to g of x into q of x. Here observe this, it is same as f of x plus inside r of x is subtracted. Look at LHS and RHS. If this RHS is divisible by g of x completely, then the left hand side also will be divided. So what I mean to say is, whatever the remainder you get, that remainder you change the sign, that should be added to the given polynomial. Then only the resulting polynomial is exactly divisible by the given polynomial. So let's try doing that. Let me divide f of x by g of x. Divisor is x square plus 2x plus 3. Sorry, minus 3. That's why I have to be very careful while writing. F of x is 4x to the power 4 plus 2x cube minus 2x square plus x minus 1. So let's do this. The first term is 4x square, x to the power 4. When 4x to the power 4 is divided by x square, I'll be having 4x square. So 4x square is the first term. I'll multiply. I'll get 4x to the power 4. This becomes plus 8 times of x cube minus 12 times of x square. Change their sign. Add them. This get cancelled. Plus 2 minus 8. The resulting number is minus 6. Minus 6. X cube plus 12 minus 2. The resulting number is positive 10. So plus 10x square plus x minus 1. Look at the first term, minus 6x cube. Divide by x square. I get minus 6x. So when minus 6x is multiplied, you get minus 6x cube. This second term is minus 12x square. Third term is positive 18x. Change the sign again. These first terms they get cancelled. Plus 10 added to plus 12. Resulting number is plus 22. So plus 22x square. This is positive 1. Coefficient of x is 1 here, positive 1, minus 18, the resulting number is negative, minus 17x minus 1. Now I need to multiply 22, so plus 22, multiply, I get 22x square. 22 multiplied to 2 is 44, so plus 44x minus 3 multiplied to 22 is 66. Once again change the sign. The first term is 22x square, cancel. Minus 17 minus 44. The resulting number is minus 61x plus 65. Look at this. This is our remainder r of x. I'll say that this is the remainder. The reason is the degree of this minus 61x plus 65 is 1. The degree of the divisor x square plus 2x minus 3 is 2. Since the degree we are getting is lesser than the degree of the divisor, this is the remainder. So now then conclude that minus r of x, which is plus 61x minus 65, to be added to f of x, so it will be exactly divisible by g of x. Isn't it simple? Divide using long division method. Whatever the remainder we get, negative of that remainder to be added. Very simple. Sometimes the question can be like divide 6 plus 19x plus x square minus 6x cube by 2 plus 5x minus 3x square and verify the division algorithm. Don't get confused with this type of question. What we need to do is we have to consider these polynomials f of x and g of x by rewriting the given polynomials in standard form. What is the meaning of rewriting polynomials in standard form? It actually means arranging them in descending order of the power. So this is a standard form of this polynomial. Same way, g of x. The standard form is minus 3x square plus 5x plus 2. Now you can continue division. As you can try this, we get some reminders. On division, we get some reminders. Now you have to verify this. How do we verify that? So f of x equal to g of x into q of x plus r of x. We will be getting some quotient here. This quotient and the remainder are to be substituted here. If LHS and RHS, if they become equal, then it is verified. You try solving this question. Let me give an hint. The hint is the second polynomial g of x is a factor of the first polynomial. With this hint, you will be able to guess now. Remainder is 0. Then find out the quotient. Check whether division algorithm is satisfied with the quotient you obtained. Do this. In our next session, we will try solving exercise questions, some important questions. I'll be giving some more questions to practice.